Hey everybody, Mark Z here. Welcome to Supercharged. We're here on a beautiful summer day, Farmington Hills, Michigan at Bosch. Bosch, of course, is a very famous company, great engineering, great products. We're going to go inside and check out some other interesting new technology, fuel cells. Let's go in and check it out. Hey Matt, great to see you.
Mark.
Thanks for letting us come by and sharing with us. This is pretty cool stuff here.
No, happy to have you. Thanks for coming, and thanks to all the viewers out there as well.
Oh man, we're going to learn a little bit about fuel cells and what you guys are doing here. So get us started. Is this a fuel cell right here?
This is a fuel cell system.
Wow.
And at Bosch, it's part of our kind of technology highway of one of the options that you can have to meet what our end customers really want. So a PEM fuel cell system produces 0 emissions, which is really great. It's an alternative to battery electric technology, which we feel fits really good for heavy vehicles that need to travel long distances or recharge quickly. This system is a 224 kilowatt system that was designed for heavy duty trucks.
Well, it's pretty hefty then, huh?
It is hefty. So we really started from heavy duty as our focus market. You know, a long haul truck needs to drive 500 miles on a single, charge.
Wow.
And hydrogen fuel cells can do that. Very similar performance to a diesel truck that they're used to today.
You don't need a big battery.
No, you actually need a very small battery as well.
Yeah. Well, you still need some smarts in there, and that's where you guys come in, right?
Bosch, we like to think of ourselves as a technology company for sure. But this is really one of our big undertakings as a complete system. This is, for the most part, a plug-and-play drop-in for a diesel engine. So this fits into the engine compartment of a Class 8 semi-truck. And here we're featuring 2 systems we call twin box. So we actually have 2 modular systems.
I see really 2 ECUs there.
Exactly. Yep. So this is the fuel cell control unit, which will read in all the sensors, control the actuators, and make sure the stack, which is the heart of the system, is operating properly. For that to happen, you need a couple things. You need hydrogen gas. That's usually coming in from storage tanks, 350 or 700 bar. You need oxygen. We actually take that oxygen in from the ambient air. Not a supercharger, but like a turbocharger. So we're compressing the inlet air 2-3 times, provide higher power density for the fuel cell system. We need cooling. We need electrical. So it's a high voltage operating system. And we can charge a battery or directly drive electric motors.
So I'm really intrigued about that compressor there. That's really, I would have never thought that. That really is boosting the efficiency quite a bit, I imagine.
And it also has an exhaust turbine on it as well. So we can recover energy and help to further improve the
So you should take it to the Dream Cruise over here on Woodward
That's
someday.
coming up, I think. Yeah. No, we'd love to see that. Definitely.
So let me ask you another question I mean, we've seen, I'm an electronics guy, and ECUs are familiar to me, but you probably have some communications that these guys talk, some kind of CAN bus maybe?
Yep, exactly. So with heavy duty vehicles, we use the SAE J1939 communication protocol. The fuel cell control unit is acting like the powertrain controller, and it speaks to the vehicle control unit. That vehicle control unit will decide for the driver's demand, how much energy do I need from the fuel cell versus coming out of the battery. So that'll set the split as kind of a hybrid system.
So I got to ask you another question. I mean, this looks, if you take a look under a hood in a heavy duty truck, it looks like it should fit. I mean, is that how you guys are planning it, right? There's some mounting points here.
Yeah, exactly. No, it does fit. This has been on the road, actually. So we actually went into production back in 2023. And globally, we have over 7 million miles on the road.
Wow.
So it fits, it works. And then you can do some different things with the system to design it for other vehicles. So transit buses, vocational trucks, even much smaller systems into forklifts, material handling. So it's a very flexible system that you can use. And you mentioned diesel. Everybody thinks hydrogen fuel cell is very complex. Again, very similar to a gasoline or diesel engine and what you need to operate it.
Fill her up. How do you get it full anyway? We'll see.
Right, so you have the hydrogen tanks, which will be on the vehicle.
Yeah.
Those communicate with the refueling station. There's another communication protocol over infrared.
SAE standard.
Another SAE standard as well. So actually a couple. One is handling that communication protocol. Another one is monitoring how fast the tanks are being filled, temperature, pressure, to make sure it's done at the right time and efficiency.
Right.
Because again, instead of charging your battery for hours, you can refuel in minutes.
Right. So you were talking about range extending, and this seems like a perfect match for that technology. So how does that work?
No, it really is. And a fuel cell at its heart is a serial hybrid range extender. So you still have a high voltage battery, but much smaller. And instead of using gasoline or diesel, you have the fuel cell providing the energy, again, local zero emissions, to charge the battery or drive the electric motor. So here we can achieve diesel-like range even in a 80,000 pound truck.
Okay, Matt, on the back side, what do you got going here? A little voltage, a little higher voltage, huh?
Yeah, yep. So it all starts with the fuel cell stack, as we already talked about. So those stacks are inside these housings. So that's where the high voltage direct current is produced. And that comes through here, a power distribution unit. So again, anywhere 250 up to 400 volts. And these are connected in parallel. You can also have them connected in series, or then you're at 700 volts. Now to get to a battery, typically 800 volts in that range, we have a DC to DC to match the voltage to the batteries. So those high voltage connections would be here. The DC to DC in our Gen 1 is located on the vehicle. For our next generation systems, that will be directly on top, integrated as an add-on feature from Bosch.
So how does the high voltage work though? Is it on demand, or this really goes to a small battery pack first? Yeah. And that's where the demand is from?
It's really both. It's based on this vehicle control unit and the customer's strategy.
Yeah.
But you can have more of a base load, kind of steady state operation. You provide maybe 100 kilowatts generally, and then let the battery handle, kind of the dynamics. Or you can have a much faster operating system, more of a load following system, and then you really ramp up and down the operating to match what the vehicle needs. So really both is possible with a PEM fuel cell. It's one of the advantages.
Oh, interesting.
Yep.
Interesting.
So in addition to the electrical system, we also have the blue connection, so we have coolant. So it's a typical engine coolant, glycol based. The one very important factor, it's deionized water. So this cooling water is flowing through the stack, it's flowing through the system where we're conducting current. So we need to have deionized water so we don't have any short circuits or increase of conductivity. So that is the one difference, but glycol mixture.
Backside, you got a lot of engineering going into this.
Yes. Yep.
I mean, you probably, the development has been on, couple seasons that you've been working on it?
At least, yeah. No, really a decade or more.
But it's pretty mature now, right?
Yes.
It seems like it could hit the road, or it has hit the road already.
This one has already hit the road, and now we're talking about next generation, which I'd love to share some more details with you.
Excellent.
So this system, as I mentioned, is the twin box, which is designed specifically for long haul trucks. 224 kilowatts, it works, but we see in the future we want to go to higher power systems. So we have the next generation system, the Compact 300. We showcased this at ACT Expo earlier this year, and this will be ready in the 2028 timeframe. But this is also designed for heavy duty trucks and really enables them to drive further, have more power, even reduce the battery size further. And off of that, we can create other modular, smaller designs. We have the Compact 190, 190 kilowatt system, which then fits other applications like vocational trucks, garbage trucks, cement mixers, as well as buses. And then we can go down to other smaller systems as well. And at the heart of it is the stack. And this is one of Bosch's core technologies, the PEM fuel cell stack.
What is a stack? Is it made up of layers of a chemical type of a material, right? There's something that absorbs the oxygen molecules.
So it's an electrochemical process.
Yeah.
So it's a PEM fuel cell, proton exchange membrane. So it's a PTFE-based membrane today, which has multiple layers on it. And the big key is the precious metal platinum. The platinum will cause a reaction of the hydrogen, will split the protons and the electrons. The protons need to flow through the membrane, again, proton exchange membrane, and it forces the electrons to flow outside. And then on the cathode side, we have anode and cathode similar to batteries. Then we combine with the oxygen, which is also reacting on the catalyst, and your only byproduct is water. So really water vapor, water droplets coming out the tailpipe, zero emission, zero local emissions.
Simple physics.
Yeah, and again, it's been running. NASA's having different types of fuel cells running for decades.
Yeah. And then you're doing some testing over here.
Exactly, this is a key part. So we have a system test bench at a Bosch sister company has designed. So Moldwald, or Bosch Manufacturing Group, based out of Germany, has designed this test bench. And this can test up to 400 kilowatt systems. And as you can see here, some German nomenclature. Bosch is a German company. I myself spent 3 years in Germany. It's been a little while there, but
Guten Tag.
Ich kann ein bisschen Deutsch. Yeah. But no, we really work very closely with our headquarters, and it really gives us a global presence. And we support our customers locally here with test benches, with engineers who can go to the field, go to the vehicles. So what this system is doing, so we have the same system as we saw there, and we're simulating it on the test trolley, the so-called wagon number 8. So here, this is simulating everything that's on the vehicle, the cooling system, the electrical system, really handling everything on the vehicle, and the test bench surrounding it is then simulating the environment, temperature, pressure. It's also handling the safety concept as well.
So you mean these doors close on the test chamber? And
this will close.
Can have heat or humidity in here, is that it? Or
not so much. It's not an environmental chamber, but it'll regulate. You know, also the room here, the test room is regulated.
Right. So you have a controlled environment.
We have a controlled environment, which is very important.
Yeah. Right on.
Yep. Exactly.
Right.
And we mentioned safety. So everybody thinks hydrogen, you know, but there's a couple different layers of safety. One is the system itself. We have sensors that are able to detect leakages in the system. We're able to handle that properly. Our friend is always ventilation. The more we can ventilate any hydrogen leak, there's no risk there. So the system itself has the sensor technology, the computing power to handle that. Then we have the test bench. Also ventilation in the test bench. We're also monitoring, again, the operation. So a very safe environment that, again, has been running for a while.
In the storage, on the onboard storage, hydrogen tanks, what pressure are those? Because you're saying you boost that when it enters, that pressure enters the fuel cell. Is there a big step up there?
So actually we're stepping down.
Stepping down?
Yeah. So on the vehicle today, a lot of buses have 350 bar tanks, gaseous. New trucks in kind of the future is 700 bar. You can get more range, more energy density into the tanks. And then there's 2 step down stages in that. We have so-called medium pressure range. So we step down to around 15 bar, which we then enter the system. And then before the stack, we step it down again with the hydrogen gas injector or a control valve to about 2 to 3 bar, depending on the operating point.
Boy, it's just kind of the opposite way from a fuel injector diesel engine, right? It's a little bit, boy, fascinating technology.
Yep, it really is.
Where do you get the hydrogen from?
I'm glad you asked, Mark. Now, this is really one of the points of hydrogen fuel cells today, or hydrogen combustion engines also. We need the infrastructure, we need the fuel. So one way that we do that, and Bosch saw the need, is through electrolysis. So this is a PEM electrolysis stack. So a fuel cell running in reverse. So now we're inputting water, we're inputting electricity, we're outputting hydrogen gas, and our byproduct is oxygen. So when you power this with renewable energy, wind, solar, hydropower, even nuclear, would be 0 carbon emissions, produce hydrogen and then consume it in a fuel cell, really end-to-end 0 carbon. So with renewable energy, a real game changer in the decarbonization for not only mobility, but other sectors. This is used in a lot of industrial applications as well.
So it looks like your design here is pretty compact and portable.
It would be. It's very heavy, so you'll need the equipment to move that. But no, it is very compact.
Yeah.
And we talked about 200 kilowatts on the fuel cell system. This is 1,250 kilowatts maximum power.
Right.
You can produce 23 kilograms per hour of hydrogen from this stack, and you can operate up to 34 bar outlet pressure. And then what the system integrators can do, and we work with a number of partners in the market globally, they can integrate this into a container, multiple stacks, or even a large plant. So you get up to 10, 50, 100 megawatt, in the future gigawatt scale as we start talking about some of these large, solar field, wind farms, all of that.
So do you see any real challenges? I don't see any real technical challenges with the adoption and implementation and rollout of fuel cells,
I mean, with everything, there's technical challenges. Lifetime, we want it to last as long or longer than
durability,
diesel. So durability. But really the biggest barriers we see today are infrastructure. Where do you refuel the hydrogen? Most of the stations are in California today. And what's the price of it? What's the price of the hydrogen? So we really need to drive those two things down. And we need scale, we need technologies like this. And Bosch is one player to help to do that.
Outstanding. So if you, just maybe one more question, I'd love to take a ride in a truck with one of these things. You've been in.
I have been, yes.
Yeah, and can you tell, I mean, you probably can't tell the difference, or maybe you can, because it's electrified, it really takes off.
Yeah, no, that's a great point. So it has an electric powertrain. So it's a very similar drive to a battery electric vehicle. So a lot of instantaneous torque, a lot of takeoff, very quiet operation, and really fun to drive. We hear from the fleets, the drivers, like they're fighting over getting into the fuel cell trucks. They don't have the diesel, impact. They don't have the shifting, everything. So it's a really great driving experience as well.
Well, we enjoyed the experience here. Thanks for walking us through. This is really cool stuff, and
happy to share, and glad to have you here, Mark.
All right. Well, I still want that ride in the truck someday.
All right, we'll set you up with one.
All right. Thanks, man.
Thanks, Mark.
Have a supercharged day, everybody.